Welcome to Mr. Benjamin's Math World. Today we are going to be working with perfect cube of binomials. This binomial, two terms, is to the third power, which means multiply a plus b times a plus b times a plus b 3 times. Instead of multiplying all that, a plus b times a plus b, get the result, and then multiply times a plus b, there's a rule that is applied to this factoring, which makes the steps easier and faster. And it is factored as follows. A plus b to the third power. First term, second term. The rule says the first term to the third power plus 3 times, always 3 times. The first term to the second power times the second term plus 3 times the first term times the second term to the second power, and the last one is the second term to the third power. And now we need to solve this. But the most important is always make sure that your exponent or the addition of them is always the number 3. This is the first term to the third power. The second term is also to the third power because 2 plus 1 is 3. This one is also to the third power. The third term to the third power plus 1 plus 2 is 3. And the second term is also to the third power. And now we solve this. This will be, bring down the a to the third. 3 times a to the second times b is positive 3a to the second b plus 3 times a times b to the second is 3ab to the second power plus bring down the b to the third power. If you notice, the exponents for the first term, they go in descending order. This is 3, 2, and 1. And the exponent for the second term goes in ascending order. This is 1, 2, and 3. So the first exponent goes down for the a, descending order, and for the second term, the b, it goes in ascending order, which is 1, 2, and 3. So a plus b to the third power is equals to a to the third plus 3a to the second b plus 3ab to the second power plus b to the third power. Let's see our second exercise. Number 2 is very similar to number 1. The only difference is the sign between the two terms. We are going to use the same process. The only difference will be that our first sign will be negative and then positive and then negative, alternating it. Negative, beginning with a negative sign, positive and negative. And that's going to be the only difference. Let's solve. A minus b to the third power is equals to the first term to the third power minus 3 times the first term to the second power times the second term plus 3 times the first term times the second term to the second power minus the second term to the third power. Solving, bring down the a to the third power minus 3 times a to the second times b is 3a to the second power b plus 3ab to the second is equals to 3ab to the second power minus b to the third power. The exponent for our first term, 3, 2, 1. The exponents for our second term, 1, 2, and 3. Our third exercise says 2a plus 3a to the second to the third power let's use the same rules we have used before. So this is the first term to a to the third power plus 3 times the first term to a to the second power, the 2 outside, times the second term, which is 3a to the second, the 2 inside the parentheses, plus 3 times the first term, which is 2a, times the second term, which is 3a to the second, but to the second power, plus the second term, which is 3a to the second, to the third power. Once again, we have 3, we have 2 plus 1, 3, we have 1 plus 2, 3, and the number 3. Let's solve the powers. 2a to the third power means 2a times 2a times 2a, which is 2 times 2 times 2, which is 8. 2 times 2, 4, 4 times 2 is 8. A to the third power. Why to the third power? Because a to the third means a times a times a. And when you multiply a times a times a, remember you add the powers. 1 plus 1 plus 1 is 3. So it's a to the third power. Here it is. Plus 3 multiply times 2a to the second power is 2 times 2 is 4. A to the second power times 3a to the second power. Plus 3 times 2a is 6a. I can multiply right away, which is 6a multiplied times 3a to the second, which is 3a to the second times 3a to the second. 3 times 3 is 9. And a to the second times a to the second is a to the fourth, because we add a to the second times a to the second equals to a, and we add 2 plus 2 is 4. We add it. We do not multiply the powers, we add them. A to the fourth power, here it is, plus 3a to the second to the third, which is 3a to the second, times 3a to the second, times 3a to the second, 3 times. 3 times 3 is 9, 9 times 3 is 27, and then a to the second times a to the second times a to the second is, let's fix this, 27, a to the 6. Because we're multiplying a to the second times a to the second times a to the second, we add 2 plus 2 plus 2, which is 6. Let's solve this. Bring down the a to the third power, plus 3 times 4 is 12. 12 times 3 equals 36. A to the second times a to the second is a to the fourth power, because 2 plus 2 is 4, plus 6a times 9a to the fourth. Let's multiply the coefficients. 6 times 9 is 54. And then a times a to the fourth, we add 1 plus 4 is a to the fifth power. And then just bring down the 27a to the 6. Now, let's take a look at the powers for the variables. We got, it goes in ascending order. 3, 4, 5, and 6. And this is the way you solve a perfect cube of binomials. If this video was useful to you, please feel free to subscribe and activate the bell in order to receive further notifications. See you next time.